So we got this bunch of values, so we first and foremost add 3. So obviously we create, maybe say this small say box, right? So this is a small box, contains all the small values, but what we actually apply to this is a max heap function into it. So on the contrary, we have the opposite, the large box over here, and the spell that we actually cast towards this box is the max heap into it. So now every time we add the value, it's always add towards the small box for the most parts. So if we were to actually call it, is that operation Z is very much that we every time we add a value, instant add towards the small box. That's what we're gonna do. We instantly add this guy into, say, the small box. So we have a 3 over here. So there's nothing to actually compare yet, so we're just gonna move on. We add the second value, is a 2. So obviously same thing, operation Z. So now the thing is this, like we do the operation Y, we start to actually compare say the size of the boxes, and if it's like, say, more than, say, if it's like at least a value of 2, we need to actually do a sort of like transfer from the small box. We need to do a transfer. So obviously when you take out from small box, you have like the spell of like the max heap, you're gonna like remove like the max value over here. So in this case the 3 will get transferred over. So now like the next operation, you're gonna add 7, right? So now operation Z, add a 7, and now you're gonna compare. It's not 2, but the thing is this, there's another operation, is operation W. Operation W is basically asking that you say that if my small box, is it more than your big box? So you're comparing basically 7 and 3, and obviously 7 is more than 3, so you need to do a transfer. So therefore you do I think a swap. So for this case, remove the 7, and I think the 3 will come over here, and then the 7 will come over here, and then last you add the 4 come into the small box, and then you compare the size. It's like 3 against 2, so that's fair. But then you do small versus you compare the small box and the big box. And for this guy, I think it will be, say, the 4 versus 2, 4, 3. Oh yeah, here got 3 value, here got 1 value. And so you need to transfer one of the values, and you need to transfer the 4 over. So 4 will actually come over to here. So at the end, you get the median value, and so for this case is you bring the guy from small box, and this is a whole new operation, maybe say operation J, where you bring out from say the small box, and then you bring out the value from the big box, and what you get is basically the 3 and the 4, 3 from the small box, 4 from the big box over here. So and then you obviously need to divide by 2 because you're finding the median, and then you will get your value and then return back to the system. So they also actually discuss about like saying that, okay, I have this box, sure, and then I apply the spell say max heap, and the thing is that say I want to push a value in, so push a value in, it would usually cost you log n, and usually when you actually pop the value, it also costs like log n, and this one is like the cooldown and the cooldown, and the mana that it actually do cost is actually n to actually produce out this heat. And to actually find the value, so maybe say I need to find the value, it actually big O of 1. So this is the items that I kind of like discovered as they were like explaining about like this whole problem set. Yeah, I mean like for this main character wise that we talk about, it's basically talking about heap, and we were very much using 2 of the heaps, both the max and the minimum. And also like the intuition is this, that this small box whatever we need is basically the max value to bring out, because intuition speaking, like you're saying that this guy is a small box, so what is his purpose? His purpose is actually to get small values. So obviously when you want to actually take out value, the taking out value will usually want to be big. Therefore we actually do cast the spell of like the max heap onto the small box, and kind of like vice versa for this. So and in terms of like the rule book, whatever they actually do ask us is that they constantly want us to actually add numbers into it, and then they want us to actually find the median for uh, the items. And with that, like the moment that you want to find median, that means maybe you can split them into two categories. So whatever like our algorithm is doing, we are very much splitting our uh, our array into like two boxes, and then having like these two boxes, we actually am able to actually find the middle value. And that was like our algorithm that we actually create to actually solve this whole thing, if you were to actually look it in the big picture view. I mean, like the moment that you see this creating two boxes, I mean creating a box, um, and then like the main thing is this, like you want to find the middle value. When you want to find the middle value, pretty much you can find the max of like one box and find the minimum of like the other box. And when you talk about that, like you having like a distinct point of view, because imagine you have like two a box, and then you split them into two. When you want to find median, you want to find the extreme end of like of a box over here and a box over here, which is the extreme ends. In this case, extreme ends. And usually when you want to find extreme ends, it's usually max, median, minimum, and that will actually leads us to actually talking about max or minimum over here, and the max or minimum will fall under the category of like heap per se. And yup, with that, everything comes to an end.